Hello guys, in this video tutorial I would like to explain line plot in R. Sometimes you need to draw a line plot or line plot with some dots, where you noted the observation, and you can draw different data sets for comparison purposes or model validation, statistical model validation, etc. So let's move to the R studio. Okay, this is the code which I developed for line plot. Let's read the data. This is the same as I already explained in my lecture how to read data in OR. X data is assigned to X read.csv, and this is the file name, which is R99p. This is the file name. Just run this. Okay, again it's working. Now let's see what is in the data. So you can do this. Just run this command hit X. Okay, let's do like this, little more space for this. Then we can see what are there. Let's do this again. You can do this by using the upper arrow key. You will see the command and then just click enter. Okay, so we have this type of data. Let me run this again. Okay, I think there is enough space. Let's do it more. Okay, okay, so there are 1, 2, 3, 4, 5, 6, 7 columns are variables. This is here, and then this is the observed data, and this is for different model simulated data. So you can do a comparison of these models there, which models perform better. It is not the final decision. You can do other things, but I will just say you can do a comparison up to some extent by using a line graph. You can use other graph as well. So we will do subsetting here as well as we did in my previous lectures. I mean that we'll draw this plot for this variable, and then we will add this as a line, and then this, and this. So let's move to the code. See how we can do that. Okay, we just check the data, what is the data, and you can, by the way, see dimension as well, which I did on my previous lectures. So the first command is very important, and I will show you the whole command. What is this? Plot x, and then these brackets you can say. So this means this is the subsetting for the the second column, and I don't need to draw the first column because that denote the years. This is, you can see here in this panel. So I'm drawing the first. This is observed data. I'm plotting this, and remember that the type as I will see now L, and then I will explain for O as well. So this mean line color of this line should be black as I'm choosing, but you can choose other color as well. LWD line width S2. On main, I don't want to plot anything else. Main mean on this, on the top of the plot. X lab, on the X lab, these are the years, so I'm just printing times in years. Y lab as precipitation in millimeter. You can write about your own variable on y-axis in this way. And call dot lab, color for the label as 1, so that is black. You can change this. I will just try this. That's how we can change the color. Just okay. This is the observed data has drawn. You can change the color because I don't need label again and again, so I'm just using labels here, and the label color is here. Let's try for 2. You can see 2 is red. You can say 3. If you want different color, you can use. This is green. You can use 4. That's that's blue. You can use maybe 5 if you're interested in different color. That's yes, another color. But I'm interested in likes because that's look like better in this case. So this is now the basic framework has been developed for the graph and the first line has been drawn. You can check if you want to just to check where in the what is the function of this main. So just write Dr. FKY and just try this again. You will see Dr. FKY is here. So whatever you want to draw on the top of the plot, you can write main and then here. I'll just remain this empty because I don't want to write anything else. Okay, so this is again the same plot and with the x-axis label and y-axis label. Now I need to add another line. So again, you just need to use because the type of this plot is L. So I'm using line because L is stand for lines. So this is now lines. This will add data 3, the variable 3 with different color and the same LWD. Yes, this is another variable. And you can use this command lines and you can use a different variable. Now the fourth column or the third variable. And then again, but remember you should use different color because then that will be mixed if you are not using different colors. This is fourth variable. Let's just do it again. Yes, with the green color. Now with the maroon color as the fifth variable. Okay, do it again. There is some problem with okay. And now at the end, this gray color, the sixth variable. Okay, so now you have plot the data, all the variables. Now you need to write the name up because this is the same variable for observed data and different models, simulated results. So there is a name, the name is R99P. This is the name of the variable and this is in that particular area in zone 1. So now you can write this. So this is the name of the variable. I'm using normally this because this is self-explanatory graph. However, you can use a different method. BTY mean if I remain this empty, then this will give a line around this name of the variable and this whole stop. But if you write n, then there will be no line. Just try this. Okay, I need to plot again this whole stop and then I will do this. Just do this again. And remember, I'm doing this with n now. The first one that was remain empty, and now I'm doing this with n. So you will see there is no line around this. If you like a line, just need to remain this empty. If you don't like a line, just remain it like just mention n. So there will be no line around the name of the variable. Now the important thing is legend because this graph is okay. This means that on the y-axis in the x-axis there is time, the y-axis there is precipitation, and this is the variable. But I don't know what is meant by these lines. I mean that what is red line, what is black line, what is green line, what I mean that which one is observed and which one is simulated. Even I don't know. If you are if you are just looking this graph, you will see what is mean by these graphs. So for me, because I know, so I can ask that what is mean by these graphs? I mean that which one is observed and which one is model. So you know how much variable you have. Just see a 1, 2, 3, 4, 5, 6, and different color you have used. The same color which you have used here, you need to use here. So this was the command for this I mean the name of the variable, and now legend locator 1 n equal to 1, so it means that uh, you can place this legend anywhere once. So these are the name of the variable observed. This is one model, second model, third, fourth, and fifth. 1, 2, 3, 4, 5, 6. Because there are 6 data set. You can see we remove 1. We did not plot 1, so we started from 2. So there are 6 variable. And now remember the same color, we use black for the first, red for the second, blue for the third, green for the fourth, and maroon for the fifth, and gray for the sixth. Okay, so this is for each of these data sets. And now remember that the text color should be also the same color. So text dot call, because I will draw a legend and that will give the same color. So text dot call, and then you can write. I already told you that when you are writing something like in the list, then you need to write C and then brackets and then the name of those whatever is. So this is the same color I'm using, and again BTY, that is N. So there will be no line about the legend. And CEX, this is for the text size. So if it is 1, then the text will be bigger, the large font size, and if it is small, I mean 0 0.5, the text will be small. I will check this again when drawing. Okay, so now run this command as a whole. Okay, this is run, and now again you see that there is a plus sign. This means that we can just put somewhere here the legend. So these, the name observed, the first model, second, third, fourth, and fifth. But the tick size is a little small, so you can just do this by this one. As I already told you that this is the text size, just write 0.8 and just run this. And again, just put this. You will see a little bigger, and this is, I think, clear. Observe the first model, second, third, fourth, fifth. So now this is self-explanatory graph. But you need to do this. I will draw once again because this is two time. I don't need this two time. Okay, no, I don't need this. I will explain this later. I know this. Okay, and now the name of the variable at the corner left top left. You can change the position of this from top left to top right. That will be published here. I mean, that should be mentioned here. This is now with add, and you can somewhere place here. So this is now self-explanatory graph, because on the x-axis it is clearly mentioned, on the y-axis this is clearly mentioned. This is the name of the variable, and each of line represent observed. One is observed, the black, and the other is each one is model simulated data. You can see and you can draw the patterns. You can draw the conclusion about that which model is close to the observed data. So this is one thing. Now let's me, because sometimes you see that you like that there should be some dot at the observation, like here, and like here. So for that, I develop the code. Let's do that now. Okay, the same command I'm using for this, the same variable. The only thing is I'm doing this type is equal to small o. Remember, small o, not capital O and not 0. And the remaining things are exactly the same. But you need now, like, just run this. This is perfectly working. Now you need to write the same command, but you need to mention this. If you don't mention this, let me remove. Okay, for the first time, I just run this. This is perfectly okay. And in this command, just copy this command. No, okay, remove this. Just remove this from this and then run this. This is the third variable. You will see this is simply line, because this I'm using the same command as used in the above code. So again, I will write type, and no, this is equal to small o. Okay, so now it will work. Run this. Perfectly can work. This okay, this one, okay, working. This is working. This is working. So this is the same line command, but there is a dot. There is a, you can say a small circle or dot at the observation where the observation is noted. So this is a little bit different graph. Now you can use the same thing as I did. And again, you can see, yes, you can, and you can, by the way, check, make smaller or larger the font size of the name of the variable of this. This is the name of the variable. You can make this larger font size or small font size by using this CEX equal to this one. You can make larger or smaller. Again, the same thing I will do. So now you can just locate anywhere you want. So this is now again the same plot with little different style. And now you need to save. How to save? You can save these graphs in multiple and different format, including, okay, there is some issue with this. This is not working. There is some problem. Otherwise, you can just go here and you will see different. You will see, okay, I will do this sometime. Separate video on this, how to export this. So you can see this graph that you can do. I mean that you can draw conclusion about that which model is performing better. Okay, so this is all about line plots in OR, and I hope this will help you. Uh, if you like the content, please subscribe the channel and see you in the next video. Ciao.